Now we can discuss a bit further about whether the firm has market power to influence market price and its implication for the marginal revenue. So the first case is the firm has no influence on market price. So it can sell all the output that it wish, how many as possible without having any effect on market price. So in this case, market price is constant. Then the marginal revenue will be equal to price. Simple, no? For example, you selling banana. The market price of banana is always €1 per banana. And if you sell an extra banana, then the extra revenue you get from that sale is €1. Exactly the market price of the banana, as you have no market power in banana market. Now, on the other hand, if a firm faces a downward sloping demand curve, then more output can only be sold if it's willing to reduce the price of the good that it's selling. What does that mean? Now, so the downward sloping demand curve is like this. Here we have Q, we have P. Now, downward sloping means, the slope of this demand, the dP, with respect to dQ is negative. Okay. And as it's negative, the more you go, you increase Q, the lower the market price is, right? So in that sense, consumer only willing to buy more if the market price reduce. This is what we actually learn a lot. We have seen a lot in introductory economic course, I think. So that is the downward sloping demand curve. So what is the implication of the downward sloping demand curve for marginal revenue? Let's see. All right. So marginal revenue, by definition, is the derivative of the revenue with respect to quantity, Q. Now, here let's do it a little bit more detailed now. And because of the definition of the revenue that we put on in the beginning, and here's exactly price as a function of Q, because the more you sell, the more the price decrease. We talk about it here now. So this is product rule, right? Because you have P as a function of Q, and then you have Q multiplied each other. So the derivative of that would be the derivative of first of all P, the function of Q, now with respect to Q, dQ, times the second function here is Q, right? Plus the first function PQ times the derivative of the second, which is Q itself. Okay, so this is for the first term, it is dP over dq times q plus the second is p, right? And it's exactly what is written here. Okay, keep that in mind. The implication of the downward sloping demand curve is that marginal revenue will no longer be the same as price, but it's a function of output, what we just derived. Let's write it down again here. So marginal revenue equal P plus Q times dP over dQ, right? So now you have Q over here. So marginal revenue is a function of output. That's the first thing. It depends on how much you produce or you sell. The second thing is if price falls, if price decreasing, then that is the case that the firm increases the output or the selling quantity, right? Then the marginal revenue will be less than price. How do we know that? Because for a downward sloping demand curve, the slope is dP over dQ smaller than 0. It's negative, right? Consequently, P plus Q times dP over dQ will be smaller than P itself because this part is now negative, right? So in that case, the more you increase your selling quantity, the less extra revenue you will get compared to price. Okay, now we move on to the second scenario where market price depends on the output quantity or the selling quantity of the firm. So this firm has, let's say, enough market share or market power to manipulate the market price in a way. Now, so example, let's take a monopoly. Who could do that now with the cost curve? The function of output is given by 5 plus 3q plus 0.5 q squared. Now, and this monopolist phase demand given by P equal 12 minus Q. So from this demand function, by the way, is the, even though our supply function will appear as a function Q, quantity depending on price and something else. And when we talk about the demand and supply, usually we think about the quantity, but we normally write the demand function here as the inverse demand function. So it's a function P of Q, because it depends on the selling quantity of the firm or the demanded quantity. Alright? So from this demand curve, you can see already it is downward sloping. Why? Because the slope is negative. So the more output or the more quantity of product sold on the market, price will decrease, right? And on the other hand, if firm make the output restricted output quantity, then price will increase. Yeah. So that is the power of the monopolist. Okay, so Now let's put it in a profit maximization problem. So max pi with respect to Q as before, thinking about output quantity equal P times Q minus C as before. However, now when we plug in, we don't have P as P itself anymore, but it's a function of Q, right? Times Q minus the cost, right? Let's put a bracket in before, easier to see something later. Q squared. Okay, that is the profit definition. We could also distribute the Q into the first bracket. So here the decision problem of the monopolist is, okay, if it make the product scarce, so it's kind of restrict the selling quantity, then of course price will increase. Now, but then it's selling less and have less revenue. First case. The second case, if it wish to sell more, according to this demand function, if it sell more, increase quantity, the price will decrease. So the revenue will be lost in a way, right? So that is the decision problem here, is to choose a proper compromise between these two problems so that the profit is maximized. Which level of output should it choose to produce or to sell, and how that would affect the price. Alright? Let's set first order condition. We have that before, nothing changed over here, d pi over dq. So derivative of profit with respect to quantity equal the first bracket, 12 minus 2q, right? Is it now trivial to you? I trust that. The second bracket, 5 second, 3 plus 0.5 times 2, the exponent, right? So this is 1 and then q. Now, equal 0. But let's take a moment to remind ourselves this is the marginal revenue and this is the marginal cost. So as always with profit maximization, marginal cost should be set equal to marginal revenue. So that is where or how much they should produce. Okay? And now we could already solve it. So we have 12, simplify everything, minus 3, right? So 12 minus 3 is 9, right? And then minus, here minus 2q, here's minus q, so that is minus 3q equal 0. And then we have q star equal 3. So this is the quantity that the monopolist should produce in order to maximize the profit. And then now the next question is, if it's produced at this price, this quantity, what will be the market price? Because it has the power to influence the market price, right? So substitute into demand curve. That means here, right? So that is the demand over here. we have P equal 12 minus 3, which is 9. So that is P start, the price, market price, which is actually, at this stage, you can already call it the equilibrium price of the market. Yeah. And for this, let's calculate the profit. So the profit will be we could distribute this and simplify it before we calculate the profit, would be less messy. Now, so 12Q here minus 3Q over there, so 9Q minus Q squared minus 0.5Q squared, right, and minus 5 equal 9 times 3, 27, right, minus 0.5 times 3 squared is 9, so that is 13.5, and then minus 5. At the end you have 8.5. So that is the profit. Yeah. That this monopolist will get as his maximized profit. The next thing I would like to show you is some graphical illustration of this situation. Wait. Okay, now let's do some graphical illustration of this monopolist situation. However, there's one thing that I forgot previously, which is the second order condition. So you can actually deduct some of my points somewhere if you have a trading sheet somewhere now. So the second order condition say that the second order derivative of profit with respect to Q must be negative, right? And here we have the first derivative is 12 minus 3Q minus 3. So the second derivative, which is nothing but the derivative of this term, is minus 3, right? So it's negative. That means it's a true maximum, not minimum. Alright? So now let's draw. The thing to realize here is I wrote down again the marginal revenue, marginal cost, and the demand function of the situation. And they're all functions of Q. So we could actually combine them in one graph of Q against cost or revenue. So this is Q, and this can be either P or C, cost, but per unit of product. Okay, let's first start with the demand curve. So the demand curve, in this case, I mentioned that now normally they draw it the inverse demand. So P on the vertical axis. So that is the intercept in 12. We need something like this. Okay, so that is 12, 3, 6, 9, and here's 12. Now, And then here, let's also 3, 6, 9, 12, right? The intercept is 12. The slope is -1. That means if you set P equal to 0, then Q equal also to 12. That is here, right? Let's hope that is. It's not. I'm trying to sketch a line and it's not even straight. Yes. You have to use your imagination a little bit here and there when I sketch something on a graph now, because it's not always exactly what I wanted to show. Anyhow, okay, this is the demand curve. All right. Do something similar with the marginal cost curve. So rate, which is the intercept here now. However, now the marginal cost has positive slope. So let's say if we take Q equals 3, then MC equals 6, right? So 3, 0 is 1 point. Sorry, 0, 3, and then 3, 6 is another point. Should be around here now, and the MC should be like this. This is MC. How about the marginal revenue? So intercept is 12 again here now, but now the slope is also negative. We could just do everything over there. So I need new markers already. Okay, so that is if you set MR equals 0, then Q will be 6, right? So it should be somewhere here, Q 6, MR equals 0. And I will connect these 2 points. Yeah. So it will cross the MC, the MR will cross the MC exactly at Q equal to 3, where the profit of the monopolist is maximized. So MC equal MR is the most important, the most basic condition of profit maximization. Doesn't matter if the firm is monopolist or a price taker. Up to this point, you should remember that. Now, however, keep that in mind. Here, the MR is 6. Now, at this point, right? But the price of the product sold on the market is 9. This is what we found from profit maximization. So, end up actually somewhere here. Now, this point should be on the demand because it's where the market is willing to pay for that product, right? So you can see like this is what actually mean with the thing written on your slide, that if the firm face a downward sloping demand, then the marginal revenue is lower than the market price at any point. Why? Thinking about that intuitively, because of the dilemma that I said earlier. Now, the moment the monopolist sell one more or a few more units on the market, it will have to reduce the market price because the demand is looping. Consumer willing to buy more only when market price decrease. Now, so the moment it sells some more units on the market, price decreases, right? Make a decrease in price. So that's why the revenue, the marginal, the extra revenue from selling these units will not be exactly as the market price at the moment it's selling. Okay, because price moving somewhere already. Yeah. So from here, we could actually see where is the revenue and where is the profit of the monopolist. Quite interesting. So where's the revenue? Revenue is just simply price times quantity. So it's the whole thing over there, right? This rectangle. Now, this is the revenue. So, all right. And where is the cost? Where is the cost? I don't know if you still remember or you have watched the part where I explained to you about the integral. Remember. So this is the marginal cost curve now. So if you take the integral of the marginal cost curve from 0 until the quantity, the Q star, and here's P star. Let's write it. What would you get? You get a cost, right? And this is the area below that. Below that marginal cost curve until the Q star is here. So that is some cost, right? How to calculate this area? Requires a little bit geometric now, so that is 2, 6 plus 3, 1/2 times the height of it, also 3, right? So that is 0.5 of 9 times 3, 27 again, it is 13.5, right? So this is some sort of cost. However, it's not all cost, right? Why? Because you remember before that we had calculated the pi star equal to 8.5, right? Here you have the revenue 27. So the profit should be 27 minus the cost is 13.5, which is 13.5. And that is still larger than the 8.5 that we derived from the profit function before. Why? What do we miss? Because if you take the integrals like this area, now, below the marginal cost curve, only show you the variable cost. Why? Because fixed cost is something incurred already. So it was not taken into account when they calculated the marginal cost. So if you integral, you take this area, it's just the variable cost. You have to deduct further the fixed cost. And where's the fixed cost? The fixed cost can be seen from the cost curve of the monopoly equal 5 plus 3q plus 0.5q squared. The fixed cost is something you have paid already some point in the history and doesn't relate to how much you produce. So that is the constant over here. So that is the fixed cost. Now, and if you take 13.5 minus 5 minus the fixed cost, you get exactly the profit that we calculated from the profit function. And this point on the demand curve is normally called the Carnot point, stemming from the Carnot model of monopoly competition. Okay?